Okay, second video. All right, now here's the problem we run into with all of these problems. If you look at each problem, notice how the index number of the radicals are different. Index number of the radicals are different. Same thing here all the way through. So it's awful tough to simplify these things in radical form. So I would try to get them all out of radical form and get them in exponential form and go from there and see what happens. Okay, so let's take this top left-hand guy. And I know that I can get that guy in exponential form by writing it as 32 to the 1/9 over 2 to the 1/5, like that. Okay. Now they have different bases, so the way it is now, you can't use the quotient rule. So really what it comes down to is can I rewrite one or both of them so that they have the same base? Well, 32 is a power of 2. If I remember right, it's 2 to the 5th. So we take a look, 2 to the 5th power, okay, is 32. So I can rewrite that 32 as 2 to the 5th power, but it's that whole thing to the 1/9 power, all over 2 to the 1/5. Okay, so using power over power rule, that numerator becomes 2 to the 5/9 power over 2 to the 1/5. And notice now I can use my quotient rule. Okay, so that gives me 2 to the power of 5/9 minus 1/5. Okay, so you could do that subtraction in your head or do it on a calculator. It doesn't make any difference. So 5/9 minus 1/5, and I get 16 over 45. Okay, 16/45. Okay, now if you take a look, notice how this exponent is a proper fraction where the numerator is smaller than the denominator. Okay, so this thing is in simplest radical form. So this is one form of your answer right there. Okay, another form of your answer would be the 45th root of 2 and that whole thing to the 16th. Okay, or we can go the 45th root of 2 to the 16th, and then I could figure out 2 to the 16th is going to be a large number, 2 to the 16th. Okay, so that's more than 65,000. So I could write this as the 45th root of 65,000. What is that? 536. Okay, so if you put it in root form, it's like that. If you leave it in exponential form, it's like that. Okay, it's just a matter of how you want to express your answer. I'd say with this, with this problem, that looks a little bit better than that. Okay, a little bit simpler to look at, but it just depends on how you're trying to express your answer. Okay, so let's try that second one to see if that works out as well. Okay, so I have 16 to the 1/7 power, okay, over 2 to the 1/3. Just like the last one, notice they have different bases in the numerator and denominator, but 16 is a power of 2. That's 2 to the 4th. Okay, so I would have 2 to the 4th power, but that's all raised to the 1/7 over 2 to the 1/3. Okay, using power over power rule, 4 times 1/7 is 4/7. So that's 2 to the 4/7 power over 2 to the 1/3 power. Okay, so applying your quotient rule, that'd be 2 to the 4/7 minus 1/3. Okay, so you go to your calculator and and you go 4/7, 4/7 minus 1/3, and I get 5/21. Okay, and just like the last problem, okay, notice that the rational exponent is a proper fraction where the numerator is less than the denominator, so that is in simplest radical form. Okay, so that would be your answer in exponential form. And if you wanted to go to root form, we could say, okay, that is the 21st root of 2 to the 5th. And then I could take that 5 and put it underneath, and I could say, okay, that's the 21st root of 2 to the 5th. And 2 to the 5th is just 32. So this is the 21st root of 32. And so you have that answer. Okay, now notice both of them are, neither of them are really much more simpler than the other. Not like up here, where clearly exponential form is a lot easier to look at than root form. Where down here, they're about the same. So it's just a matter of how you want to express your answer. Okay, let's go to the third one. Let's see what happens there. Okay, so up here, well, the square root of 81 is just 9. That's all it is. Okay, so that one's easy. So let's see, that's 9 up above. And down below, I would have 27 to the 1/4 power. Okay, now both 9 and 27 are a power of 3. So that would be 3 squared up above, and down below 27 is 3 cubed. But I'm taking that to the 1/4 power. Okay, so let's see, 3 squared, and if you use power rule, 3 times 1/4 is 3/4. So that's 3 to the 3/4 power. Okay, so we can use our quotient rule. 3 to the power of 2 minus 3/4, which would give us 3 to the 5/4 power, like that. All right, now, notice how when we go to exponential form, just like up here and up here, notice that both of these rational exponents were proper fractions. Okay, so they're in simplest radical form. Now notice how this is an improper fraction, so it is not in simplest radical form. Okay, I like that. So is it one way to look at it? We could say, okay, that is the 5th power of 3 to the or the 4th root of 3. So the 4th root of 3 to the 5th power. Well, if I have 4 factors of the 4th root of 3, I just get 3. Okay, so we take a look at, and in my head, I'm thinking, okay, this is like the 4th root of 3 to the 4th power times the 4th root of 3 to the 1st power. Okay, well, the 4th power of the 4th root of 3 is just 3. And the 1st power of the 4th root of 3 is just the 4th root of 3. So we are going to get that guy. Okay. So right there in root form, that's pretty simple to look at. And up here, it's in exponential form. That's not hard to look at either. Okay, the reason I kind of like this better than that is because this is in simplest radical form and that's not. Okay, so those 3 are done. Let's see what we can do with these guys on the bottom. Okay, very similar type problems. Let's see what happens. Okay, so if I take this guy right here, all right, that's number 4. Okay, I'm going to write that as 27 to the 1/8 power over 3 to the 1/4 power. And of course, 27 is a power of 3. Okay, that's 3 cubed. So I'm going to get 3 cubed, but that's to the 1/8 power over 3 to the 1/4 power. And then using power of power rule, 3 times 1/8 is just 3/8. So I get 3 to the 3/8 power over 3 to the 1/4 power. And then using our quotient rule, so we subtract those, 3/8 minus 1/4. So let's see, that would be 3/8 minus 2/8, so that's 1/8. So this is 3 to the 1/8 power, and notice that rational exponent is a proper fraction, so that's in simplest radical form. And if I wanted to put it in root form, I could say that's the 8th root of 3. Okay, so once again, either of those two answers would be fine. We have exponential form and root form. Okay, we're okay so far. Let's go to the next one. Okay, so I get 125 to the 1/4 power over 5 to the 1/2 power. And 125 is a power of 5. It's 5 cubed. Okay, so that is 5 cubed to the 1/4 power over 5 to the 1/2 power. Okay, so using power of power, you multiply those two exponents. So 3 times 1/4 is 3/4. And then we can apply our quotient rule. So we go 5 and then subtract the exponents, 3/4 minus 1/2. Okay, so 3/4 minus 1/2 will be 3/4 minus 2/4, so that's 1/4. So this is 5 to the 1/4 power. Okay, and again, notice that rational expression is a proper fraction, so it's in simplest radical form. And if I wanted to go to root form, I could say that's the same as the 4th root of 5. Okay, and once again, just like the problem right above it, neither of them are really simpler than the other. So I'm fine with both of those answers. It just depends on what you're looking for. Okay, so let's see what we got going on here. So I have 108 to the 1/3 power. Okay, and I have 8 to the 1/5 power. Okay. This one's a little bit tougher because I'm looking at this and I'm thinking there's no way to write 108 as a power of 2. I'm sorry, as a power of 8, but I might be able to write both of these as powers of 2, because I know down below, I know 8 is 2 cubed. So that's like 2 cubed to the 1/5 power. And can I do that? I think I can do that with 108. Let me see. 2 to the 7th. No, that's 128. Okay, so let's see, that's 54. Okay. 2 to the 6th. That's 64. Let's see this guy. We got some problems there, don't we? Okay, let's see, 108. Okay, that is 2 times 54. Okay, so that is 2 times, 9 times 6. Okay, so 108 has to be 8 times something. 108 divided by 8. No. 2 times 2 times. So let's see. That would be the same as 2 times 3 times 3 times 2 times 3. So that's going to be the same as 2 squared times 3 cubed. That works, doesn't it? 4 times 27. Yeah. Okay, we got an issue here. We got a problem. Okay, so I have 2 squared times 3 cubed, but that's all to the 1/3 power. Okay, so it looks like, well, I'm going to be able to work with some of it, but not all of it, and let's see what happens here. Okay, so let's see. power of a product, so that'd be 2 squared to the 1/3 power, so that would be 2 to the 2/3 power. Oh, this is going to work out nice. 3 cubed to the 1/3 power, that would be 3 to the 3/3 power. Okay, and that's just 1. Okay, 3 to the 1st or 3. And then down here I have this power of a power, so I get 2 to the 3/5 power. Okay, so far so good. So let's see. I can work with these guys, but this guy right here is just equal to 3 to the 1st. Okay, so I'm going to put that 3 to the 1st out front, and then I can apply my quotient rule here. 2 to the 2/3 minus 3/5. Okay, so 3 to the 1st is just 3. Let's see, 2/3 minus 3/5. 2/3 minus 3/5. That's 1/15. So that's 2 to the 1/15. Okay, so I have one answer in exponential form, and then if I put it in root form, that's going to be 3 times the 15th root of 2. And let me check that too. I want to make sure I check that again. 2/3 minus 3/5. Yeah, 1/15. Okay. Yeah, that one you had to manipulate a little bit more. Okay, so that one was a little bit tougher to do. Okay, so we're good there. We got all those out of the way. All right, we're good to go. Okay, and what do you say we get at least some of these done before I shut this video down? So let's see what's going on here. Okay. All right. Well, they give you everything in exponential form. So my guess is that it's probably going to be best to leave your answers in exponential form. Okay, so let's do this top left. Okay, so in my head I'm thinking, okay, why not multiply the coefficients, okay, to get a coefficient of your answer, and then if I multiply the parts that have the same base, I can add exponents. Okay, so that would work here as well and here as well. So in my head, okay, I should be thinking, multiply the coefficients 3 times 5. Okay, and then multiply the portions that have the same base. So I would take a to the 2/5 times a to the 1/10. And then take the b to the 3/10 times b to the 1/5. Okay, so let's see, we get a 15 from the 3 times 5. And then let's see, a, okay, so we'd have to add the 2/5 and the 1/10. So that would be 4/10 plus 1/10, so that's 5/10. And then the b, well, that's 3/10 plus 1/5, so that'd be 3/10 plus 2/10, so that's 5/10 as well. Okay, so I'm going to get 15, and 5/10 is 1/2. A to the 1/2, B to the 1/2. Okay, so that would be one form of your answer, but notice A to the 1/2 and B to the 1/2, those are both square roots. Okay, so we could write this as 15 times the square root of A times the square root of B, and use our product rule for square roots, and we just get 15 times the square root of AB. Okay, so let's see. Well, I'm sort of partial to this answer, but that answer would be acceptable. It just depends on what you're looking for. Okay, so let's try this guy and let's see what happens. Okay, so if I go 10 times 1, that's just 10. And I take the m, and it would be 1/9 plus 1/3. So 1/9 plus 1/3. And then the n, it would be 1/10 plus 3/5. 1/10 plus 3/5. Okay, so let's see, 10. All right, let's see. 1/9 plus 1/3. Okay, so that would be 1/9 plus 3/9, so that'd be 4/9. Well, I need that m. Okay, so that'd be m to the 4/9. Okay, so far so good. See, this, I want to make sure I got that 1/9 plus 3/9, that's 4/9. Okay, and then n, let's see, that's 1/10. 3/5 would be 6/10. So 1/10 plus 6/10 is 7/10. Okay, and we take a look there, and that would certainly be one form of the answer. Now, notice that this is the 9th root of m, and that's the 10th root of n, so they don't have the same index number like they did over here. So there's really no way to combine them, because if you take a look at that, you know, and you keep going, you say, okay, that would be 10 times the 9th root of m to the 4th, which is in simplest radical form, times the 10th root of n to the 7th, which is in simplest radical form. And you look here, and it starts getting muddy because the index numbers are different. So this is probably your best answer up there. Okay, let's see if we can get a couple more of these done, at least one more. Okay, so let's see. If I go -2 times 8, that gives me a -16. Okay, and then I have x to the 1/8 times x to the 1/4, so I can add the 1/8 plus 1/4, and then I have y, and I can go 1/3 plus 1/6. Okay, so let's see, -16, okay. That would be 1/8 plus 2/8. 1/8 plus 2/8 is 3/8, so that would be x to the 3/8 power. And then y, let's see, 1/3 plus 1/6, that would be 2/6 plus 1/6, so that would be 3/6. Okay, and 3/8 is reduced, so I just get -16 x to the 3/8 power. And then notice 3/6 reduced down to 1/2. Okay, so we have one answer in exponential form. And notice again, just like this guy, we have different index numbers. So if you kept going, you would get -16 times the 8th root of x cubed, which is in simplest radical form, times the square root of y, which is in simplest radical form. So again, okay, this starts getting a little muddy here, starts getting a little ugly. Okay, let's get this last one done. Okay, so let's see, -1 times -1 is obviously just 1. So that guy we're gonna end up dropping off. Okay, I have an h and an h. So I have h, and I can add the exponents 2/3 plus 1/12 times k, and notice I have a 5/8 plus 1/4. 5/8 plus 1/4. So let's see what happens there. The one out front, the coefficient just goes away. Okay, so let's see, h. Okay, let's see, 2/3, I'd have to multiply above and below by 4. Okay, so that'd be 8/12 plus 1/12, so that's 9/12 times k. Let's see, 5/8 plus 1/4, so I gotta multiply above and below. So that's gonna be 5/8 plus 2/8, so that's 7/8. And then notice the 7/8 is reduced, but the 9/12 is not. So if I divide them both by 3, I get h to the 3/4, k to the 7/8. And that would be one answer in exponential form. And again, notice the denominators are different, so you have different index numbers. So if we keep going, okay, it ends up being the 4th root of h cubed, which is in simplest radical form, times the 8th root of k to the 7th, which again is in simplest radical form. And once again, notice how things are starting to get muddy. Okay, so this is the only guy up here, okay, where I would say exponential form and root form are in good shape. I actually like root form better, but down here I'm definitely staying with exponential form. Okay, so we're going to shut this video down.